And just first, I'm just going to give a short overview of what we did yesterday. Okay, first of all, greetings to all of you. I hope you had a wonderful day. Today, we're continuing with our Soroban classes. We started the first one yesterday, and this is what we did. Yesterday's objective was just to write, build, and test your very first Soroban smart contract. We also spoke a lot about what is smart contract itself and how it works when it comes to Stellar smart contract itself. And we also spoke about Rust, why was Rust chosen, and we also spoke about how when you compile a project, a Soroban project, it gets converted into the WASM, which is what the computer can understand. And we also touch on some special tools that Soroban SDK uses, the environment, the string, and vector. And there's also a bit more. And here is where you can follow to get started and set up. Make sure you have everything set up before we can proceed. And once everything is set up, we can then go and follow the tutorial. This tutorial here is the hello world and the storing data that you can follow, and it shows you how everything goes. One thing I also forgot to mention was the cargo.2ml, which is the Rust workspace. When you create a Soroban smart contract, like the very first time when you create one, you're going to see this file, and this is going to be your workspace. And in your workspace, you'll see here it's written members and equal, and then you see contract and the store. This just means that you can have as many contracts in one folder, and all those contracts are going to work independently. So you don't have to create another new folder outside this folder that you created for your hello world. So you can even keep adding more and more contracts, and you'll be able to compile whatever contract you have created. And it's also going to create a WASM that you can use to upload it to the blockchain, to deploy it to the blockchain. So this is something that you should know. Let me actually open up my folder while I'm talking so we don't waste time. So cd Soroban hello world. Okay, so I'm just gonna be opening the meantime while I'm talking. So yeah, so this is basically the idea behind the workspace that you're going to see. And you also have profile. You're also going to have in the same file, the same cargo.2ml, you're also going to have the profile. So the profile will have all these things. There's a lot of things that might not make sense. But just to have a brief overview, what it does is Rust on default, when you compile a Rust program, the file can be big. Like for example, it can be 112 kilobytes or 75 kilobytes and so on and so forth. But Soroban contract have to have a maximum size of 64 kilobytes. So you want to make sure that your file is as small as possible. So that's why we need this configuration here that basically tells it that this file should be this small. And this one, for example, if you look at debug, so here is just telling it to ignore any debug tools, anything that you are using there, for any code that you're using for the debug. And here is the panic that you're also going to be using in your project, in your Soroban project, which are both whenever, if things don't go well, the project doesn't go well, it just aborts the code itself. So there's also, what else we need to know? So the also profile release with logs, and which is useful, need to be, and this enables you to print out the debug. So they have the content directory. Here. We have the contract directly. So far, we only have one folder called Hello World. This is the only contract that we have. And what's going on here? Oh, I have no idea. Okay, let's just wait for it to load. So this is a project that we had yesterday, the Hello World. And as we mentioned, first thing that we need to do is no standard library. We need to use this code to tell the compiler that we're not using a standard library because it's very heavy. We want to be as light as possible. And here we're using the Soroban SDK. And here we also have to import what we're actually going to be using. So the environment is always there. We're always going to be using the environment. And we're also going to be using string. So there's two types of strings. You have to be very careful. There's string that Rust has that we use with Rust, and then the string from Soroban SDK. So we can still use string even if you don't import this here. Then we're going to be using string from the Rust language as we've used before. So this is just a more optimized string that we're going to be using here. And there's also vector that we used yesterday. So we're using vector because we want to print out something that points to something, like two things. There's a key and there's a value. In this case, the key is hello, which we've specified here. And the value, so the two is going to be added in the parameter. So, okay, I'm getting ahead of myself. So the second thing that after importing Soroban, we have to now write your smart contract. And abstract contract.
Sorry, Ben, we can't hear you.
Can you hear me now? Okay, let me just get closer to my mic. Thanks for letting me know. So here, after using this to tell the compiler that we're not using the standard library, we have to use this now to import the Soroban SDK. And these are what we're going to be using in smart contract because the environment is it's like the fake blockchain environment that we're going to be using, and string and vector. So this is different string that we're using. We're not using the Rust string. We're using strings that's specially created for Soroban SDK. But you can also use the normal string from Rust. Even if you don't import it here, you can still use string, but it's just going to be a less optimized string. That's why you use string from the Soroban SDK. And here in this line, compiler that we writing a smart contract. So this is going to be our smart contract name. So it's going to be pub abstract, and the smart contract name, which is contract in this case. And or we can have been hello world maybe, or anything that you want. In this case, we just name the contract, and under here is the implementation. So what function? This is where you put all your functions and whatever your smart contract is gonna be doing. That goes here, and in this case, we just want to take a parameter, just one parameter. For example, the parameter can be Mohammed, for example, the name Mohammed, or the parameter can be James, or it can be whatever. So it has to be a string that you want to put inside the parameter. So that's why we created the function, and you have to make it public. So a public function hello, and it's one parameter. So here when it's not going to be a parameter that we're going to be adding manually. This just tells us what we're dealing with the environment. We on the environment of the blockchain. And so this string is going to be in that environment. We take it as a string, and we're going to return the vector. The vector will have a string. So that's basically what it's saying here. So, and here, now, like we learn in Rust, like how to print, how to return, we dealt with vectors in Rust. So it usually comes with two parameters. There is the key, there's the key, and then the value. So the key, hello. We might as well just write hello here, but it's just not going to be optimized for us. We can write hello here. But this is this, what do you call it? Soroban, or the compiler, will see it as the normal string that we've been using in Rust, and this needs to be a less optimized version of doing that. Or we can do, like, for example, if we did this toString, for example, as we learned before. So this is just a less optimized string, but we don't want to do that. We want to use the string from, we want to use this string. So in order for us to do that, we type it out this way. So it's going to be string. So we have a word that is hello, and then in the environment, and we're converting that to a string this way. So that's how we are converting in the string in this case. And once this is over and done, we can test it. I don't know what's going on here. Don't know what's going on here. Let me just use problem. Let me see, cargo test. Okay, so this is what we did yesterday. All right. So far, does anybody has any question with what we did yesterday? Any questions? Feel free to ask. There's no stupid questions. The aim is for all of us to learn. If you're stuck, don't worry. Just now, what do you mean, Rudolph? Back environment string from string. So you want to understand that code? You want to understand that? Or the double environment, Oh, the double env. So here there is when we're calling a parameter, because we're dealing with the blockchain, the normal way, the way that we used to do it before is we don't even care about environment env. We don't care about it. We're just going to put one parameter if you need one parameter. Or let's say if there's no parameter, then there's not going to be any parameter. So this is done and sorted. But in the case of smart contract, whenever we're dealing with parameters and whenever we're going to deal, because we're dealing in the fake blockchain world, the virtual machine that has been created, we have to specify that. And this env, because we're going to be returning a vector. Returning a vector is going to string. So here, the first env that you see here, like we getting a hello from, so we adding that hello on the environment itself, and then we converting it to a string as well. And we also have to specify here that we're still in the environment. The vector is in the environment. So returning the vector.
Sorry, Ben, we keep on losing you. I'm not sure if you're turning your head away from the mic or.
Okay, let me just hold my mic a bit differently. Okay, so it's returning a vector of environment string with env and hello, and to double returning a vector of, so returning a vector of string, yes, and env string with env. And so here we're just returning a vector of, like as you say, it would say environment, but the environment is not going to be, we're not going to see the environment. We're just going to what's going to be shown to us is the hello and the key. So the environment only has to be specified when we're dealing with correct. Hello is going to be this and that. Just going to be so there's two parameters, key, and then there is the value. So that also is going to be the key, and the value also is going to be in an environment. It's a bit complicated to understand now, like based on what we learned so far in Rust. It will make sense as we work with it. So let's do something. Or in your own time, because for your you're gonna have to do this whole thing that we've been doing. You're gonna have to do this, follow the tutorials, and I'll suggest that you also play around with everything here. Like for example, instead of using maybe string that is here, maybe you remove string and then you use string from Rust. See how it happens. Maybe you use a big floating point number. Actually, you can't even use floating point here. You can't use floating point, unfortunately. But there's a way for you to deal with floating point, which we'll learn later on. So just play around with initiating a floating point. You reach But in order for you to do that, you first have to deploy, because you're gonna have to continually test. You're gonna have to test it, or you can create a script that will test already from terminal. I'm gonna show you how to do that. But anyway, so this is what we did yesterday. So let's move on to and contract build. In order, after testing, you have to build it also as well. You to interact with, and this is deploy. I'm not gonna go through that today. Just gonna fly through because I want us to put something else. So this is the code you use to deploy on the Stellar testnet. You can see Stellar deploy, and then there's WASM target. So file, what do you call it? The address, the file to look for your hello world WASM. This is exactly what's going to be the target. It's on the target. This is what's going to be used. I don't think I haven't deployed it yet. I didn't build it. So since I didn't build it, you're not gonna see it. So you have to build it first, and then you're going to see the hello world WASM somewhere there. And the source, the account source, is the address that you're going to be creating. Like we saw the previous class, you can create, it shows you how you can create a wallet that's going to have a name, like for example, Alice. And the network, we specify that this is the testnet, and then the alias for the contract. So the contract itself is going to be, you have an address starting with C, but you can also have an alias, which is going to give it a name instead of using the whole contract when you interacting with it. I don't know if it makes sense. So that's what happens, and when you want to interact, we can either use so this is Stellar contract invoke. This is how you interact with it, and the ID here is just the address that I talk about, your contract ID, or you can use the alias. ID can also be your alias. Like for example, here in this case, the alias is hello world, and the source account is Alice, the account that created smart contract, the network testnet, and here is the function hello, and under the function, that the parameter of 2 is the RPC, and then so you basically, whatever you're gonna put it here is what you're gonna be putting in your parameter, like for example RPC or James or whatever, and this is what's going to be printed out. I know it's very confusing. It's very, very confusing when you're here for the first time, but just go through it. And yeah, I just suggest that you go through all of it, and then if you have any trouble, let me know. Today we are here for this. So yesterday we created a basic hello world, but it was a contract, smart contract, a basic smart contract, but that smart contract was stateless, meaning that it only returned, it just returned hello world. Nothing was stored. But in real world contract, you need to remember things. You need to remember, for example, a balance of tokens, the record of votes, or a counter that increases every time someone interacts. So that's why we need storage comes in. And as we spoke before yesterday, We spoke about the different storage. There is instances. There is different type of storages, like the persistent storage, and that we're going to use. And for this tutorial, we're going to be using the instance storage. So the persistence lasts for very long. The instance you can extend it according to how many ledger entries you want it to survive. We're not talking about that. And this helps us to make the blockchain less bloated, because you might not want to store data for years and years and years. So we're going to be using instance for today. So there is smart contract that you have to follow that you can learn from the tutorial, using the tutorial. But I also created another code that is similar to the tutorial that we will go through, but you also notice that it's less optimized. And I want you to figure out why this is less optimized than the other one. But before we get into that, let's start coding. But this has to, I don't know why. This is, oh, terminal. Oh, I was in output. What's going on here? Okay, I don't know what's going on. All right, let me just put my mic. Okay, so far we have one smart contract, but like I said, we can have many smart contracts. We can have many smart contracts on the same full contract. And today we're going to be following this tutorial of storing data. So in addition to creating a new project, the Stellar contract init command also allows us to initialize a new contract workspace within existing project. In this example, we're going to initialize a new contract and use the name flag to specify that the name of our new contract increment. So when we use this command, we're basically gonna Stellar contract init, and then we dash the name. Then it's going to create a new folder under contract that we can use to create. So we can use another smart contract called increment. But we can also override. So if you want to override the smart contract that you have created on that folder, you can just pass in this dash override flag within the Soroban Hello World directory to overwrite it. So it's going to remove the Soroban Hello World, the Hello World smart contract that you created. So this is what we're going to be doing. So let me just make sure I'm in the right folder, because this looks very funny. Okay, I don't know why it looks like this. Looks weird. Okay, this is just going to create a new project under smart contract. It's going to be the under smart contract. As you can see here. So now we not only have hello world, we also have increment, and increment is also going to have the default codes that the hello world. But we don't want to do hello world anymore. Remove this. You name it increment. Let's see what's the name of this one here. You're gonna increment, yeah, it's increment contract. Increment contract. Can you hear me? I hope y'all can hear me. Okay, so increment contract. And also remember implementation, you also have to do the same increment. content. Now we're going to be using different things here. We want to be able to debug, to print out, to see what's going on as we're working. Like because here this smart contract will just add a number. So it's going to be storing a number, and every time we call the function, that number that is stored is going to be incremented. But we'll also want to be able to view what's going on for debugging purposes. We can use it using log. So those who have like if you know how to, if you work with JavaScript, HTML, you've seen console log, right? Like those one who have worked with JavaScript, you use console log for debugging purposes. So it's the same thing here. Here we're going to be using log, and another thing we're going to be using, we're not going to be using vector, so we can remove it. Let me just leave it. I'll some warnings, so we're just going to leave it here. Environment is going to be there. Contract implementation. We also need symbol. We're also going to be using symbol, and I'm going to tell you why. I'm going to use a macro called symbol short, and you're going to see it in action. So here, the first thing we're going to do is we're going to create a constant. Now call it counter. Okay, so this counter is going to be of the what do you call it, type symbol. And the reason we do that is we want to be able to use a symbol short, which in maximum, if I can remember, it takes 9 characters in maximum, 9 bits in max. But if I use like string, for example, or if I use any other data type, it might take 32 bits or 8 or 16 bits, or like we want to get as small as possible. So symbol short will make the name of the variable that we created, as small as possible. Because here we're dealing with blockchain, we want to be as efficient as possible. That's why in this case, we're not just calling a string, we're not just calling counter a string, we're using symbol. So it's the way to deal with that. So this is going to be of the type symbol, and we're going to PC is going to now, and we're going to take something like a string, we convert. We use this method to convert this. That's what's going on here.
We lost you, Ben.
Can you hear me?
Yeah, now we can hear you.
Oh, I don't know what's going on in my mic today. So I was saying that here we don't use string because might as well have a constant that is a string, for example. And I'm not tell you why we're even doing that at the first place, because here we're dealing with counters. Like, why do we need a string in a counter? But for now, just understand that here we're not using string, we're using a symbol. I use a symbol short. A symbol short that's going to convert character called counter symbol is just a way to create. It's much more lighter than using. So get this idea first before we can move further. I hope y'all can hear me. I don't know what's wrong with my mic. Okay, now that we have that, we're going to have now the next step here is okay, we have our contract. We already named our contract, implement contract, and now we in the implementation. So here we're going to have a function. Change the name here. Let me see if I think it's here. I'm gonna use him, but you can leave it here. Okay. And here we're gonna have a function called increment. Increment. Now instead of returning a vector, here we want to return an integer because we're dealing with incrementation. So we want to return a number. So like we've done before, so far, I hope now you know what to do here. It either is gonna be an I32 or it's going to be a U32 or whatever it is. So in this case, we're just gonna use an unsigned number called so U32. We're gonna be using U32. So, but something is wrong here. Okay. Do we really need parameters? We might, but it's not really necessary because we just want it to. So whenever we call a function, by default there should be a 0, and then if you call it again, then there will be 1. If you call it again, there will be 2. So we don't really need to have anything in the parameter, but remember, environment has to be there, as we saw in the previous example. So we are dealing with environment. So now we've created our function. Now what is going to actually happen? So here is going to be a bit tricky, and this is something that at first is tricky, but later it's going to make sense. So we're now going to create a variable, a mutable variable called count, and this count is the variable that's going to be incremented. So it's going to be 1, 2, 3, however we want to be. So this is going to be a U32. And yeah, the interesting part, we're going to be using the environment, and then we're going to be using the storage, and we're going to specify which type of storage we're going to be using here. So the storage, the debugger is even helping us. Is going to be either instance, persistent, temporary. So in this case, we're just going to follow the tutorial, but you can change later, because I also made an example. I changed everything. I changed some stuff, but in this case, it's instance, and so this is not persistent. This is an instant storage, and we're also going to now we're going to get counter that we called here. So we're going to be getting this counter. So see counter, like it's like a paper. It's the key. In this case, it's the key. So see counter as a key or as a paper where you can write anything. I can write a number, I can write a letter, I can write whatever. So see this counter that we use here just as a key or as a paper. So that's what we're going to be calling. So that's what you're going to be getting. So you're trying to get what is in there. You're getting what is in there. So if there is nothing there, then we use this method called unwrap. If it's empty, just put a 0. So that's why it's empty. If it's empty, that counter that we've created here is going to point us to 0. So this is like a long way of doing things, because why don't we just create, why are we even going there at the first place? Why don't we just create a variable and then we're just gonna call it, why are we going the extra route of now having to use a key just for something simple? So this is just for optimization. We're doing this for optimization because instead of calling a variable, the much more efficient way is to use a key using a symbol. So that's what's happening here. And next up, so we have created a variable now called new count, and then it gets the value from the counter. So if the counter, which is like a key or the paper or whatever, if it's empty, just put a 0 there. So at this point, if you're running this function for the first time, this is what's going to happen. Counter is just going to have a 0 in it. And we can now use the log to view what's going on. So how do we view what is going, what's happening? We want to view count, for example, the count itself. So here, like so far, the first run of the function, this counter have a 0, and we take that 0 and put on this variable as well. So now here we want to see what's going on. So we're going to, since we're using a parameter, again, we're using parameter, we want to get what is in the environment. We're going to do this again, the env, and we're going to print out count is, or maybe let's just do count and then curly bracket, like we've seen, like how we deal with Rust. So here we're just going to put count. So this is just going to print count. It's not going to do anything. It's not storing anything here. Here we're not storing anything. This is just for us to print out for debugging purposes. And then next up, so far we are at 0, but now we want to increment. So we want to add one number on top. So to do that is we're just going to say count plus equal 1. So now in every run of every call of the function, count is just going to be added. And notice that we call this outside the function. So count now is going to be changing. So when we're running the function again, it's just going to call the previous counter that we had, and it's going to check at the counter. So for example, if we had our first run and then count is equal to count plus 1, then we're going to set, okay, we're going to set this count to have this count plus 1. I hope it makes sense. We want to now, like everyone, we want to be able to take whatever is in this key and add a 1 to it, and then we're going to store it there so that the next time we call the function again, we're just going to call the key again. We're going to look what is here, what is in this key, what is in this space, or we can put it in 2 or whatever. So if there's a 1, then we count. But only right when it's empty. That's what we use to convert all. If it's empty, then but in this case now we want to change. We want to set whatever is in here count plus 1. That's the way to do it. We go back again to the storage and we go to the instance. It has to be consistent to the type of stuff that we use. You can see we're going to be using instance. And we use the method set to now set whatever is in the counter to count. To this count here, that you see this count here. So that's what we're doing. And it's going to change because we made it mutable. Here we are. We're just borrowing and we're just adding. So this is what's happening. So every run, we're just adding one number to the count. And then the second step, this is also a very, very interesting step. You don't have to even do it here, but for educational purpose, we're now going to tell, okay, we're going to tell the blockchain network, Stellar blockchain network, how long do we want our values to be stored in the blockchain? Like how long do you want it to be stored? Because we're using an instance, so we also have to determine how long it's going to be stored. And depending on what you write here, let's say if you want it to last for maybe 10 years, you want it to last for 50 years, whatever you're going to put it, it's going to cost you different amount of XLM. So the lower it is, the less you pay. The more time that you want it to last, the more you pay. The little it is, the little you pay. So that's how it works. So we're dealing again with the storage. We are instant storage, and then we want to extend. Here it shows us the threshold, so it's going to be 50 and then 100. So this box is telling us that we want these to last in the storage for at least 50 ledgers. For at least 50 ledgers. So look at it like, so every time there's a ledger in the blockchain, so let's say like whenever it reaches 50, so that's how long we want to last. And in Stellar, one ledger takes to create one ledger is about 5 to 6 seconds, like around 5 seconds. Let's just say 5 seconds. 5 seconds, that's how long it takes for there to be a complete ledger. So this is just going to tell Stellar blockchain that lasts for at least 50 ledgers. So 50 times 5 seconds is 250 seconds. So so it's about 4 minutes. So 4 minutes minimum, 8 minute maximum. So that's how long we want it to last. So please last for at least 50, but best case scenario, I want it to last for 100. That's what we're telling it here. I hope it makes sense. Does everyone understand? Does everyone understand? It's a lot to take. I understand it's a lot to take. For the more you work, the more you start coding, that's when it's gonna make sense. So this is what is actually saying. So we're going to extend the minimum threshold to 50 ledgers to 100. So it's gonna be about 4 to 8 minutes. But something also you have to know, this does not mean that the data is automatically deleted after 8 minutes. It's just that if it passes, for example, minimum threshold and then it passes the maximum threshold, it can still last for longer than this, but it's not going to longer be a priority for it to even stay in the network. So it can even stay for 10 days, 30 days, but you only wanted it for 8 minutes, you understand? But if the system needs to be less bloated, then it's going to be removed. So that's what happens here. So you can test this out, but unfortunately, since it does not delete automatically, then you're not gonna see unfortunately you're not gonna see it deleting in the system. Like after writing your code and then you say 10 seconds, 20 seconds, maybe you say like I want it to last for maybe 2 ledgers minimum, 10 ledgers maximum. It's not going to disappear so quick. So unfortunately, you won't be able to like see it in real time how it disappears from the blockchain itself or the test net as we are testing out. So basically, this is what happens. So we created a function that is called increment. We returning a U32. We're using a mute count variable to read what is in the counter. And the reason we use a counter was of symbol short was we want to use a key. We want to use a key that's going to point us to a number. And the first run, we're going to check if counter is a number. If it has no number, then we put a 0. So the counter is going to point to a 0, and the count is also going to be a 0. And here we just log it, and here we count, we add a 1. Here we set the count to the new value, and here we extend it to a specific time. So it's going to be 50 ledgers maximum, 100 ledgers. 50 ledger minimum, 100 ledgers maximum. So this is how the code is. So let me just compare it before I'm just going to copy and paste the test code. So let me just make sure that the variable names are the same and all that. The function name are the same. Let's see. So we go into increment contract increment. Okay. So now I'm going to use a test. So this is going to test it. So we're going to be calling. So first we're going to get a contract ID from the increment contract. And then we're going to get the client. And from here now we're going to be calling the function. Then afterwards, what we call just means that make sure that when you call this called increment, first one is going to be 1, second one, third one, 3. After the function call, and then there's a new number that is added. New number. Use these to test out our code. The same concept that we used in our previous class. We're gonna go to test, and just gonna paste it and save. And here we're just gonna say cargo test. What is going on here? Cannot compile. Implicit return, expected U32 found. Oh yes. Something that I forgot to do here. And I did not return. You have to return something here. And remember, we don't put a semicolon. Right? You don't put a semicolon. So this is what's going to be returned. So we're going to be returning counts. So the first count that's going to be returned is going to be count plus 1 because count is 1, and then when you go down, we have a 1 here. So that's what's happening here. So now let's cargo test. And you'll see we're getting a warning here. We have vector, we have string, and we have vector here. So these ones were not used. So just like we use Rust, it warns us. So for optimization purpose, you have to make sure you don't have this here. So you have to remove vec. You also have to remove string because we don't use it. Alrighty. So yeah, the test passed, but now there's also a way for us now to debug and to see what's going on, what is actually being printed. So to do that, we use cargo text, no captures, if you want to see the log. So this is what we use to see the logs. I'm gonna paste it here. And doing that, I forgot to remove this as well. Okay. So doing that will allow us to print out that. You can see the first is 0, and the reason we see 0 here and not 1, we're expecting, according to the test, we're expecting 1, 2, 3, correct? But why is it printing out? Why are we seeing 0, 1, 2? This is just because of where we placed the log. We placed the log before the count plus 1. So the log is here. So the first log is when count is equal to 0. And then the second is when count is equal to 1, sorry, and then count is equal to 2. So the code runs from the top to the bottom. That's why we're seeing 0, 1, and 2. Our test passed. So yeah, that's it for today. That's the code for today. But before we leave, I want you to go through this code as well. It does the exact same thing, but here we're using the persistent, and the other thing that we didn't do here, we didn't use symbol short or anything, and we just call a string directly. So we use this, here we're using a string. No, let me not even talk about it, because I just want you to find out why is this less optimized. Why is this a less optimized way of doing what we did? And I also want you to read the code to understand what's going on here and compare it with the other code. I put some to see what's actually happening. And you can also add the log. You can also add the log for you to see what's going on. And just command that you use this command, cargo test, no capture, to see what is in the log. So just play around with it. Play around with it. And if you need to break it. So far, we working with the ugly part, because we're not really seeing anything. We don't like we're just seeing what's in the back end so far. So it looks very ugly as far, but later on, as we move ahead, we'll be able to now take whatever is happening on the blockchain in front of the user on the front end. But for now, please go through all this, and for your homework, going through what we did so far. So setting up and creating a Hello World project, play around with it, and then deploy it to the testnet. I didn't show you how to do that for the sake of time, but just follow the instruction here. If you stuck somewhere, let me know. And then you go to storing data, follow the tutorial. This is what we did today, and break it as well. And go to my code and try to find out, try to see the differences between my code and this one, and why did I use persistent instead of instance. So try to understand the difference of the different ways of using the storage. And for extra, for those who want to go a little bit further, I want you to figure out how you can add the get current value function to the contract, and also try to find if you, and also add the reset function to set the function, to set the numbers to 0. If you call that function, you set the number to 0, and also the decrement function to decrement the number. So try this just to get familiar with how it works here. I know it's very confusing when you just look at the code. It's very confusing. There's environment storage, instant get, all that. Like, what is it? But if you break it down, if you just break it down piece by piece, it makes sense. This, we're gonna be using this a lot. This just tells you that you're dealing with the storage. You want to make some changes in the storage. I mean, here you want to get something from the storage. And here you want to set something to a storage. You want to change it to, you want to make something in the storage, and then set whatever key that you have into whatever number or whatever you want to put, as long as it's the same type, the same data type. So I think we got a little bit ahead of time. I apologize for that. I'm gonna end it here. But if you have any question, please, even outside the class, let me know, because I don't think today we had enough time for you to ask questions. And thanks for coming this evening. I really appreciate it. So next week, we're going to continue. And I please forgive me. Like, I was hoping that we'll finish next week, but it doesn't look like it's going to happen. We'll need an extra 2 days to really get into that. And even later on, we'll need extra time now to work with front end. Maybe we'll have some coding sessions, maybe in the weekends or whatever, where we help each other build application with front ends. And maybe form a community. You understand? Maybe form a community where we all help each other. So thank you guys. Next week, Monday, same time. Take care.
Thanks, Ben. Enjoy the week. Cheers, guys.
Cheers, everyone. Hey, Rudolph, you say something? We could potentially. Let me end the recording.